If we are given with a graph, we can identify whether the graph or the equation that is the source of the graph is a function or not using the vertical line test. From the name itself, if you have this Cartesian plane, simply draw an imaginary vertical line, and if that vertical line intersects our graph at exactly one point, automatically that graph and its equation is a function. Let's consider this first graph here. This is a line, hence this is from a linear equation. If we're going to draw a vertical line, we consider that there's only one intersection between the graph and the imaginary line. Hence, this graph and its equation is a function because for every x value, there's only one value that we can draw upon. Now, no matter where you're going to draw the vertical line, whether here, 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 or here, we can see only one intersection, and hence it's a function. Specifically, the name of this function is a linear function, and its graph is a line. Second is if we have this given graph here, this is what we call as a parabola. If we're going to draw a vertical line here, we could see again one intersection. And whether you're going to draw vertical lines elsewhere, we could only have one intersection on the graph and that imaginary line. This is also a graph of a function. Specifically, this is a parabola, a graph of a quadratic function. Aside from this, we could also have other graphs, including the vertical line test. We have the exponential graph, only one intersection. We could also have the absolute value function. We only have one intersection. And even trigonometric functions, let's say cosine, even if it's almost debatable that there are some intersections, that there's only one intersection, and cosine is also considered as a function. This is all according to the vertical line test. Now, what if we have this graph here, the graph of a circle? Now, you could debate that if you're going to have a vertical line somewhere here and tangent to that circle, then there's only one intersection. But the vertical line test should be true for all, because once you examine a certain imaginary line where the intersection is more than 2, that would mean that this graph is no longer a graph of a function. It's because for a certain x, there are two possible values of y. We have the first intersection y sub 1 and the second intersection y sub 2. And this is actually in problem with the definition of a function, because for every value of x, there's only one value of y. Again, the equation of a circle, or this graph of a circle on the Cartesian plane, is not a function. Another example is actually the parabola when drawn sidewards or opening sidewards. If we're going to draw a vertical line somewhere here, again, there are two intersections. Now, this is how vertical line test is very important in determining whether a graph is a function or not. Once we have a graph, but of course all graphs came from equation. So once you have an equation and you could have a graph, you can always determine whether the equation and its graph a function or not using the vertical line test. We will have more examples on this on our channel, so please stay tuned and visit our channel, and of course subscribe.